When you are a beginner, this method will be extremely useful for you. Before you write your program, and debugging the program is easier because the logic is very clear in your mind. If the logic is not very clear in your mind, what you end up doing is you print different variables, you play around with your program, you change your variables, you assign different values, and in spite of all that, you would find that your program is not working. But the logic, if it is very clear in your mind, your program is going to work. You just convert that logic into the program and that's going to work, and the debugging will become much more easy. Let's take this problem. We have to check if a string is a palindrome. So you know what a palindrome is. If you read it from the left or right, that it would be the same. So small examples of it, radar, level, etc. From the left and the right, the word is the same. Before we write this pseudocode, let's get an understanding about how to use the loops and indexes. So let's take a simple problem to understand how the loops and the indexes work. So assume that we have got marks of 4 subjects for a student and we want to get the sum of it. So it is very simple. What we want to do is we just want to add all of them together, and so this is how we would do it manually, right? Now, in the programming language also, we can write sum is equal to marks 1 plus marks 2, etc. Now, this is not why we want to use a computer for. We want to use it for maybe any number of marks. So, it could be 1000 marks. So, for example, it could be that we want to get an average of marks for a subject for 1000 students. So, in that case, we want to add 1000 marks and divide that by the number to get the average. So if you want to do that, this method is not going to work. So that means we need to generalize and we have to get an easier way for us to get the sum. So we would start with 98, and what we would do is we would add 92 to 98 and 81 to 98, etc. So let's write our pseudocode also in the similar way. That means our first sum is marks 1, and to that we want to add marks 2, and to that marks 3, etc. up to marks n. N is any number. So this doesn't look very neat. So we have a similar, same format starting from marks 2 onwards, whereas marks 1 is standing separately here, and marks 2 onwards, now we have a different format. So for us to generalize, so we can generalize from mark 2 to mark n, and it is sum is equal to sum plus marks I, whereas I takes the values from 2 to 3 to n, and we have a separate statement as sum is equal to mark 1. So this is a little ugly, it doesn't look very neat. So what should we do to generalize it further? So if you look at it, sum is same as sum is equal to 0 plus mark 1. So this 0, if you are saying a sum as 0 and substitute that value here, so you can say that this statement here is same as this statement, right? And initial value of sum as 0. So now you can see that we have generalized this for all the values of marks. So now you can see that we have generalized this for all the values of marks starting from 1 to n. So the generalization is easy. Sum is equal to sum plus marks I, and I takes the values from 1 to n. But this is more a mathematical expression, but now we need to tell a computer language to do this. So we use a for loop to say for I is equal to 1 to n, sum is equal to sum plus marks I. So this has made this expression simple. But there are some areas which you need to consider when you write your pseudocode and obviously your program as well. What if you got a marks list which is empty? No one has entered any marks in it. So manually we know it's empty, there is nothing to calculate. But if you write a program like this, so the program is going to look at marks I, and marks I is not existing at all, right? So this would throw an error depending on the language which you are using. It can maybe take some garbage value from the memory in some languages, or in some languages it could throw an error. So you need to consider. So before you do any of this, you have to first check whether the marks is empty or not. So we have written a for loop here, which is a single loop, and we are using I as the index. In programming languages, it is always discouraged to use single alphabets as variables. You are not supposed to write A is equal to something or B is equal to something, but I, J, K, etc. are exceptions when you write loops. So it's easy for anyone to understand if you have I or J or K for you to write your loops. There are situations where we need to use multiple loops. A multiple loop would look something like this. For I is equal to 1 to n, for j is equal to 1 to m, do something. So this do something would be repeated n into m times. First, the value of I would be 1. As value of the I as 1, this inner loop would be executed m times. And again, the value of I would be 2 and the inner loop would be executed m times. An example to the multiple loop. Let me show you how do we use multiple loops. Again, a very simple problem. As in a school, each class has 30 students, and we need to print the names of all the students from class 1 to 10, and the output should look like this: class 1 and the names of the students below, and class 10 up to class 10 the name of the students below. So here we want all the students' name to appear together. That means they go in an inner loop. So we can say for j is equal to 1 to 30, print name j. The outer loop should be for the class. So for I is equal to 1 to 10 and for j is equal to 1 to 30, print name j would show us the output as what we have shown earlier. So now let's come back to the palindrome problem. So assuming the word is radar, what do we do manually to see whether it's a palindrome or not? We can check the first and the last letter, second and the last but letter, and since they are the same, we can say that this is a palindrome. So what is the step 1? To compare the first and the last letters. And if they are not the same, then we can say it's not a palindrome. We don't have to do any more checks. But if they are the same, we have to continue. So we have to continue with the second and the fourth, the last but one letters. So if the letters are long, then we keep continuing. So the question is, when do we stop? How many times we have to continue? How long we have to run our loop, right? So let's take this example radar. We did two comparisons. We did compare R and R, and A, and concluded that this is a palindrome. A longer word like Malayalam, we have to do 4 comparisons: M and M, A and A, L and L, and A and A. A shorter word called noon, again 2 comparisons. So these comparisons are the same as length of the word divided by 2, the integer part of it. So in this case it's 5 divided by 2. So we can use that for our pseudocode, for our program. And we have seen already what are we doing here? We are going from left to right and we are coming from right to left. That means we need 2 indexes, one going from left to right and another one coming from right to left. So the index I has to be initialized with 1, the first value, and j has to be initialized with the length of the word. And then we have to keep incrementing I and we have to keep decrementing j. And how many times we need to do it? We have to do it length divided by 2. And if we don't limit this by length divided by 2, we will not know when to stop. We'll just continue till the end and we'll continue, our loop will continue forever. So that is not the right thing to do. That's why we are trying to figure out how should we limit how many times this loop has to run. So with this, now let's write our pseudocode. Our step 1 is all the initialization. So we know I has to be initialized as 1 and j as the length of the word. And what do we have to do next? With the value of this I and j, we compare whether the word I is equal to word j, and if they are equal, we go to step 3. Step 3 is what? We increment I and we decrement j, and again go to step 2 and repeat. Now when they are not equal, we can stop. We can say that this is not a palindrome anymore, and we can type that it's not a palindrome. Now let's introduce a counter to figure out when should we stop doing these comparisons. So let's start with again the initialization, I as 1, j as the length of the word, and let's have this counter. This counter will increment, and when the counter is greater than length divided by 2, so we have to stop this problem, right? So in the step 2, so step 1 was about the initialization. Step 2, we compare the word I is equal to word j. So initially I is 1, j is the length. So the first and last letter we compare. And if they are not equal, so immediately we can assign a result as not a palindrome. And we go to step 4. Step 4, we just print the result. Now, if they are equal, what we need to do? We have to go to step 3, where in the step 3, we will increment I, we will decrement j, and we will also increment the counter just to show that we are doing our second comparison. And if the counter is greater than the length divided by 2, then again we have to exit. So if it is not, then we have to go to step 2, keep doing the comparison. And so when do we come out of this step 3? When the counter is greater than length by 2, we stop all the comparisons and we come out. So this is what we have written earlier. We are printing here the result if the word is not a palindrome. But when do we print if it is a palindrome? So far, nowhere we are writing the result as a palindrome. So one of the ways to do is in step 3, we increase the counter. And if the counter is greater than length by 2, we can say that so far we are finding this word as a palindrome. So maybe result as a palindrome, right? So here we can do that. So there is a better way for us to do this, and this is something which is used in a lot of similar examples. We start with a positive case. So we can say that the result is a palindrome. Until and unless we negate that, if we don't get this result as not palindrome, when we go to the step 4, when we print the result, so we are going to print this result if we have not negated it. Let me repeat that one more time. So we are in the beginning, we assume that the result is a palindrome. If it is not, somewhere we are going to reassign the result a value as not a palindrome. So in either case, when we go to the step 4, we get the correct result. Okay, so this is one of the Boolean variables we can use here as well. We can say palindrome as true here, and if the words the letters are not matching, we can say palindrome as false. And in step 4, if palindrome is true, we write it's a palindrome, or else we write not a palindrome. So we will write more programs to get a better understanding of how do you write pseudocode. So as you see, it's not about how do you write your pseudocode. It's about how do you introduce logic into your program. Even if you don't write the pseudocode, you have to have the same kind of logic for your program as well. So it's very important that you keep that in mind and make sure that you understand your logic very clearly. So this would tell you how do you initialize your variables, what kind of comparisons you have to do, and how do you print your results. All that will be very clear when you write something like this. So that's for now. Thank you.